All right, so this is a solution guide to today's homework accuracy. The homework accuracy problem stated that we were to find all of the zeros. Now, all is important here in that it does not say all real zeros. We're supposed to find every single possible zero. Now, it also states to list all possible rational zeros. Now, as a practice, it's a good idea to know what zeros you're looking for and how many zeros we will need. So looking at my degree, I know that there will be a total of 3 zeros. And I need to find 1, okay, graphically or using the rational zeros test so that I can make it a quadratic, as I know how to solve a quadratic. Now, using the rational zeros test, the rational zeros test states that if we take the factors, okay, of the constant, now the constant being in this case 20, so if I take all the factors of that, plus or minus 1, plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20, okay. If I take all of those and I put them over the factors of the lead coefficient, there's 2 f's in coefficient, which in this case is just 1. Well, that will give me all possible rational zeros. Now, you can go ahead and you can distribute the 1 to each one of these and rewrite it. I'm not going to take the time to do that right now, but that would be a more complete answer. Now, to find this, I'm actually going to go ahead and utilize my calculator. In this case, I see that there's plenty of options, and I want to narrow it down as best I can. Now, if you plug this into your calculator, you should get a graph that looks like this. Okay? Now, depending on how well you can see the graph, it's fairly obvious in this case that it just goes through -2, and we can verify that by hitting second, graph, or table, and looking for when y equals 0. And we can clearly see here, maybe you can't see quite as well, I think it's a little better right there, that when x is -2, y is 0. So x equals -2 is our y-intercept. Now, if we don't luck out and it's not available on the table, then what we're going to go ahead and do is we're going to hit second, trace. Now, second trace actually gets you to the calc functions or the calculate functions. We want to calculate our 0. Now, in the past, I've told you to use the cursor button to try to get to the left of our x-intercept and to the right for the bounds. Now, what I've found recently is that we can simply enter it. So if I look here, I can clearly see that x equals -3 is to the left of our x-intercept. So I am just going to hit negative, oh, I'm a little off there. If I just hit negative, I just hit -3, well, I know that that is to the left of my x value. So if I want a left bound, x equals -3 will work. Now I need a right bound, so I need to pick an x value that is to the right of my x-intercept. Now I could pick 0, -1 is pretty obvious as well, so I'm going to go ahead and just enter -1. If you hit enter, it'll ask you if you're ready to guess. I said yes, and it verifies that my 0 is at -2. I know it's a little tough to see, but the idea is that you can hit second trace or second calc and then enter an x value to the left and an x value to the right. Okay, once you grab the calculate feature, that's probably even worse. and determine that one of our zeros is at x equals -2. So now we have 1 0, we need 3, and another feature that you can tell from our graph is that this appears as though our graph only crosses the x-axis in one place. Bells should be going off in your head that those other two, okay, remember we need 3 zeros, those other 2 zeros more than likely are not going to be real. They are not going to show up on our graph. Now we need to verify that, and we need to find out what they are. The way we're going to verify this is we are going to divide our equation so that we can take, if we take x to the third and divide it by this factor, well, that'll bring it down to x squared, and we know how to solve quadratics. We can use the quadratic formula. Let's not get ahead of ourselves, though. We're going to take the -2 and divide it into our function, making sure that if we skip any powers here, that they're still included in our synthetic division. Well, in this case, they're not. We have 1, 4, 14, and 20. Drop down the 1. -2 times 1 is -2. So I have a 2 here. -2 times 2 is -4. I have a 10. -2 times 10 is -20. Add those up and I get 0. What this means is, because of the remainder theorem, okay, it means that f of -2, remember I use -2 here, is equal to 0. Meaning that when x is equal to -2, my output is 0, which lands me on the x-axis. Okay, verifying that x equals -2 is an x-intercept, or in other words, a 0. Now, remember, this was an x cubed here, and I just divided it by the factor x plus 2. Okay. Well, and again, x plus 2, we can get x plus 2 simply by adding 2 to both sides and setting this equal to 0. Well, if I divide that by an x, well, x cubed divided by x gives me an x squared. So this is an x squared, 1x squared. This would become x plus 2x, and then this would become a constant, plus 10. Now, we're still looking for the 0, so I want to know when that is equal to 0. Now, if you try to factor this, and if you're good at factoring, it's not a bad idea to check. We're going to find that we're looking for two numbers that multiply to equal 10 and add to equal 2. They don't exist. So we will need to use the quadratic formula. Well, the quadratic formula, x is equal to -b, or 2, and I can label these here. I have a 1, so a is equal to 1, b is equal to 2, and c is equal to 10. -b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. Now, if you're looking ahead, you can see that the 4 times 10 is going to give us a -40, and we're subtracting that from 4. So we are going to get some imaginary numbers here. Okay. And we get -2 plus or minus the square root of 4 minus 40 over 2, which is equal to -2 plus or minus the square root of -36 over 2. Well, -36 can be rewritten as -2 plus or minus square root of -1. Actually, let's say the square root of 36 times the square root of -1 all over 2. Okay. Moving right along. Well, the square root of 36, I'm going to get -2 plus or minus, square root of 36 is just 6, times, well, the square root of -1 is defined as I, all over 2. Now, I can distribute that division to both these terms, which will in the end leave me with -2 divided by 2 is not 0, don't do it, it's -1, plus or minus 3 3i. So our zeros, if we want to list them over here, we can write that x is equal to, well, we can't forget our original 0, negative 2. And then x is also equal to negative 1 plus 3i and negative 1 minus 3i. Now, this question doesn't call for it, but we could also find the factors from this. Well, if we write these as three separate equations, x is equal to negative 2, x is equal to negative 1 plus 3i, and x is equal to negative 1 minus 3i, well, I can add 2 to both sides here, and I see that I have a factor of x plus 2 that's equal to 0. So that's one of my factors. If I add 1 to both sides, that'll cancel this. And then if I also subtract 3i from both sides, I'll be left with 0 on this side. So I have x plus 1 minus 3i is equal to 0. And by the same method, with this last one, I can add 1 to both sides to cancel that, and add 3i to both sides to cancel that term, leaving me with x plus 1 plus 3i is equal to 0. So my three factors are these three. And one statement that we've made in the past, and I cut off my I there, is that f of x is equal to a product of its factors. So f of x is equal to x plus 2 times x plus 1 minus 3i times x plus 1 plus 3i. If you were to go about it and multiply this out, which is something you are required, or you do need to be able to do, you would find that this multiplies out to equal our original function.